Okay, so now we're going to talk about question number 3. In question number 3, example 9, it asks, if an earthquake occurs at 8 hours, 50 minutes, and 40 seconds, what time did the P wave arrive at a seismic station that is 2,600 kilometers away? So remember that this is where an earthquake starts to focus. The surface where the earthquake starts is called the epicenter. The P wave arrives first, the S wave arrives second, and they travel towards where they're getting detected at a seismic station where they have the sensors, the seismograph. So this is asking if an earthquake occurs at 8 hours, 50 minutes, and 40 seconds right here. What time will it take for the P wave to arrive at the seismic station that is 2,600 kilometers away? So we need to figure out, even though the earthquake occurs at this time, when will the P wave actually get to the seismic station? Because the seismic station is 2,600 kilometers away. We're going to go to our chart. And to figure out when the P wave will arrive, we need to figure out how long the P wave takes to travel a distance of 2,600 kilometers. So we're gonna start in our x-axis to where we have the distance. Our distance that the P wave has to travel is 2,600 kilometers. Here's 2,600 kilometers. We're talking about the P wave, so I'm going to go up to my P wave curve and go towards the left. And it takes my P wave 5 minutes to travel 2,600 kilometers. So if an earthquake happens at 8 hours, 50 minutes, and 40 seconds, my P wave will arrive at the station 5 minutes later because the P wave takes 5 minutes to travel that distance. So I'm just going to add 5 minutes to this when my earthquake happens, and my P wave will arrive at the station at 8 hours, 55 minutes, and 40 seconds. So this just means that my earthquake happened at 8 hours, 50 minutes, and 40 seconds. My P wave took 5 minutes to actually arrive at the station from the earthquake. So even though my earthquake started at this time, my P wave arrived at the station 5 minutes later. So my P wave arrived at the station at 8 hours, 55 minutes, and 40 seconds. Go ahead and pause this video to try example 10. So, example 10 asks, if an earthquake occurs at 2 hours, 11 minutes, and 20 seconds, what time did the S wave arrive at the seismic station that's 9,000 kilometers away? So, we're given the distance, and we need to figure out how long the S wave takes to travel 9,000 kilometers. And that way, we can figure out that if even though the earthquake happens at this time, we can figure out when the S wave actually arrived at the station. So the S wave is traveling 9,000 kilometers. We're going to start with our x axis. Here's 9. 9 represents 9,000 kilometers. To figure out how long the S wave takes to travel 9,000 kilometers, I'm going to go up to my S wave curve. I'm going to go towards the left on my y axis, and it takes the S wave 22 minutes and 20 seconds to travel 9,000 kilometers. So even though my earthquake started at 2 hours, 11 minutes, and 20 seconds, my S wave will take 22 minutes and 20 seconds to actually arrive at the station. So to figure out when my S wave arrived at the station, I'm going to add 22 minutes and 20 seconds to my earthquake start time. And I see that my S wave arrived at the station at 2 hours, 33 minutes, and 40 seconds, even though my earthquake actually happened at 2 hours, 11 minutes, and 20 seconds. And that's it for the video.